Welcome to the R video tutorial on artificial neural network models part 2. Okay, here we're going to actually talk about how R can do some artificial neural networks, and we're going to start simple with these. We're not going to go crazy or anything like that. We might go into TensorFlow later, but right now we're going to just start simple. So the neural net package, usually which comes with most installations of R or RStudio, is already on your computer. There's another package, RSNNS, allows for you to make neural networks which have more layers, so more of the deep learning type neural networks. And the ANN2 package is a newer package, and it's based on C++ implementation. It works really well if you can get it installed on your machine. Sometimes that can be a little bit of a trick, but you're going to have to install the packages, and once you've done that, things will work pretty easily. Now, there are packages that are in development that use TensorFlow, and RStudio is one of those who are pioneering it, not trying to advertise for them, but it is something that you can look into, and as we go along, we might play with some of their tools just so you can have a sense of what it is, and if you go on a job interview and somebody says TensorFlow, you'll at least have some sense of what that is. But we're going to use the ANN2 package, so you're going to need to install that on your machine. All right, so we're also going to work with the Pima Indian data. This is common data that's quite popular because what you're trying to predict is whether a person has diabetes. So if you have the Pima data set, if you don't, it's on the repository. You can go dig it off. You can find this data in Kaggle or lots of other places. So it's pretty easy to get. The data that I have out there does not have a header in it. That's why it says header equals false. And if you look at it, you have V1, V2, V3, V4, V5, V6, V7, V8. And I will allow you to go to the internet and find those, whatever the variable names are. But this is one that we're interested in. This 1, 0 is whether or not they have diabetes or not. All right. So now that we have this, we're going to say, consider the Pima data. And what we're going to do is we're going to do what's called data splitting. We're going to split the data into a training set and a validation set. And here we're not going to do equally balanced or anything like that, but this is our first attempt at actually looking at data splitting for a way to evaluate a model. So here I have what I call train one index. And here's the assignment operator. I'm going to use the sample function because I want it to randomly sample the number of rows in this data set. So 1 through 768. I want to randomly sample those. I want to grab 500 of them. And I don't want to replace any of them. We don't want with replacement sampling. We want sampling without replacement. Then what that's going to do is it will give me row numbers of the data to keep. So when I come to train 1, I can just say, give me data 1, where train index, and that will give me those rows. And you should be typing this in on your computer so you have this code, and you can run it and see what it does. You'll end up in this one. This data set will have 500 rows in it of the data. Now, if you go to valid 1, we're going to do data 1, and we're going to put a minus sign in front of train 1 index, and it will give us the other 268 observations in this second data set. What we're going to do is we're going to train on the training data set, and then we're going to see how well it predicts the validation training set. All right, so here's where we start getting into this. Remember, if you aren't up to coding, this isn't on the internet, so you're going to have to maybe push pause here to keep up. So if we get going too far ahead, just hit pause, and then you can pick it up as we go along. But I'm going to call this ANN1, I'm going to assignment operator neural network. This is defining it. So I'm going to have my train 1 data set. These are the predictors, and the train 1 column 9 is the one that designates whether they have diabetes or not. Okay, I'm going to have hidden layers. Now, this is why we needed to look at the hidden layers before. So I'm going to have 8 nodes in my first hidden layer, 12 nodes in my second hidden layer, and 4 nodes in my third hidden layer. So this is a deep network. Okay, and the reason I'm letting you see this is that's why you need to pay attention to those numbers before, was so that you can correctly specify this. This is not a regression type model. Our output here is 1 or 0, so regression is false. And since it's false and we're trying to predict, the loss type is going to be log. And we're not going to go too deep into what this loss type is, but it's what it uses for training to come up with the best model. All right, so here train 1 is our Training data, hidden layers allows us to specify the structure or the architecture. Regression specifies true, continuous outcome. False is if it's going to be a classifier, and here we're classifying. And the loss type log allows for classification. All right, so if we take this, the next thing we're going to want to do is once you've run that, it will train the network up to a certain point. What we're going to want to do now is generate predictions. So I called this pred.valid1, and I'm going to predict ANN1, but I have new data, and this is my valid data set, columns 1 through 8. And then what I can do is once it's generated those, I can look at a table and see how well it predicted. Okay, so I can see that 0 means they didn't have diabetes, 1 means they did have diabetes. So I can see of those who didn't have diabetes, it predicted correctly that 140 of them did not have diabetes, which is pretty good. Of those that did have diabetes, it predicted that 53 of those people had diabetes. Now, here's the real interesting thing is, of the people who had diabetes, it predicted 34 of them did not have diabetes. And of the people who did not have diabetes, it predicted that 41 of them did. So this gives us a 72% correct classification rate. So how you calculate that is you just add down the diagonal and then divide by the total number that's here. All right. Now, what you can do with this is you can train the model more. So you're not stuck with just training it once. You can see if you can improve the model. So from our last one, we had a 72% classification rate. What we can do now is try again. We're going to train it. We're going to train it on the same data that we had before. We're going to generate new predictions. So I'm going to have pred.valid2, do the exact same thing, come up with this table, and then this one is the one that allows us to sum up the diagonals and divide by everything that's there. So you might want to hit pause and type all this in so that you can have this for later. Okay, so now we've redid this, and we have 148 correctly classified here, 55 correctly classified here, which is an increase. This went down, and this went up. So not everything gets better, but it did get better overall and gave us a 75.7% classification rate. And you can keep doing this process and keep doing this process until you arrive at a best model. So once we've had this, and we can train this too much, we can overtrain this problem. Okay, you can overtrain a neural network and it will not be able to predict well outside of its validation data set. Its training data set. But here this training is helping us because we're looking at it against a validation data set. And as we go along, we're going to try to go towards something that's more like tenfold cross-validation. And yes, while there's packages that will do this, we're going to learn how to do it the hard way so that you will always be able to do it no matter what platform you're on and whether or not packages get updated or not. You'll just be able to do it and it'll work fine. All right, so see you in the next video.